Today we're going to look at an improved version of the Swarm intelligence, which features improved refactoring of the code and communications within the Swarm. Let's just run it and see what happens. When we start running this, we initialize the Swarm and then we generate system messages for our Swarm elements. We're going to be generating, I believe, 5 of them. Let's check. Actually, yes, 5 system messages. Each iteration is going to have 3,000 tokens. And it also comes up with a name for the project, and then it generates a folder for it. As you see right here, multi-snake game with Pygame, and then we are generating initial responses from the Swarm. We will receive 5 responses based on different system messages, directed by different system messages. Oh, and our question was, write the full code for a snake game with Pygame. 3 snakes move automatically towards the food. There is a user snake which is also competing. Keep track of the scores. Snake wrap around the screen. So this was our original user message. Anyway, after generating initial responses, we actually write them to all responses.json along with their respective system messages. This is the system message. This is the response. This is the system message and response, such and so. And then we start the Swarm communication, which iterates, giving all the responses to each element and tries to improve upon it. Now we're going to be doing it a total of twice. You can see the iterated code here as well. So we wrote the original responses, then the first iteration, then we'll write the second iteration, and then we'll write the synthesized response. I have actually made a video on this earlier. It is the Swarm Intelligence Blueprint video. The link should pop out on your screen as well, but feel free to watch that. That was an earlier attempt. Here we are done with our iterations. These iterations were the communications within the Swarm, and then we wrote the synthesis to a file. This was the last iteration that is written, and this is the synthesized response right here. In this case, we get a detailed description. We can use this with GPT-4 to generate the game. I've actually done this earlier. And here is a snake game that was generated with only one AI snake. As you see, the red is the AI snake, which tries to move to the, it actually got there ahead of me. So the red snake is being controlled by AI, and the green one is me, and I believe AI beats me every time. Anyway, this was one attempt. I also had another attempt right here. This is with 3 different, let's see, they're all the same color actually. I'm not being able to control any of the snakes. Here is another example. With 3 snakes, I am the white one. So I was able to get the first 2. The other 3 snakes are AI controlled. So this wasn't directly an output from the Swarm. I actually had to reiterate on it one more time, I believe. But the general code was correct. As you see, the scores are updated on the terminal as well. We can also use it for other tasks, such as comparisons, compare SQL to NoSQL in every possible way. Let's just run this. And the same process will repeat. We'll initialize the Swarm, write system messages. You're a database expert, compare SQL to NoSQL. You're a historian, provide a comparison. You're a data scientist. You're a business analyst. You're a software engineer. So each element in the Swarm, each agent in the Swarm will approach the situation from a different point of view. We will be creating it. We are using function calling and generating a name for the project, and we are actually keeping everything neat in their respective folders. As you see, we have created SQL versus NoSQL comparison, and all the files will be written under here. We will be reviewing the code shortly, but these code files will be available at Patreon. We will be reviewing the code in 2 stages. First with the Swarm GPT refactored, because I did some refactoring to object-oriented programming to manage everything better. And then finally, the Swarm GPT agent with communication. Both of these files will be available at my Patreon at the connoisseur level, $30 level. And if you become a patron, you will not only support me in my future coding endeavors, but will also have access to 120 plus coding project files, which all revolve around GPT. If you take a look, this was the original responses, and then after iteration and communication between the agents, we get a separate response, and then this is our second iteration. You can choose different models for different parts of the Swarm. This is our synthesized response right here. I mean, we can read it, but I'll just let you read it if you like by pausing the video. Requirements for this project is pretty light, only OpenAI and term color for colorful printing to terminal. Let's start with Swarm GPT refactored OOP. At the end of this file, I have a quick documentation. If you read this, then you will understand more or less what's going on, and this will give you a great understanding over the communication.py as well. At first, we're doing all our imports. We are using threadpool executor for parallelism, and then we have a config class, which includes how many system messages to generate. This will determine the population of agents in our swarm. Span token length can be anything you like. We use this to guide the model to a word count, plus also use as max token for the GPT API call. Model for system message generation, you can specify here. Model for answer generation is right here. And then model for synthesizing final response right here. And we set the API key, just like this. So this is all in our config class. Then we have an OpenAI API caller. We set the API key. Then we define a call API method, which takes in a model, messages, temperature, max tokens, functions, and function call. Then we create a GPT call parameters. The reason why we're doing this is that we can pass these as they are to the GPT call, and we can also actually check if we're doing a function call or not. If we're doing a function call, then we can add the functions and the function call, just as like this. That's why the function and the function call is set to none, so we can actually have a single method which deals with both function calling API call and otherwise. And then within this method, we try to make a call to OpenAI completions with all the parameters, .GPT call parameters. That's why we actually created this dictionary, so that instead of defining it separately right here, we can just insert this dictionary and we can modify this dictionary with conditions. So this is a really cool way to actually modularize your API call. Anyway, then we get our response. Of course, we are using streaming true. The streaming true as a key in GPT call parameters will be entered to the call, right? So then we'll receive streaming responses. So we check if it's a function call. We do streaming function call, just like this. Otherwise, we just do streaming with the regular content, and we just return the responses. If this API call fails, then we print the exception. And then we have another class called GPT Swarm, which initializes with user message, GPT API caller, and system messages, which we receive from config.how many system messages. Remember, we had created that class up here. And then we are initializing some attributes. And system messages is the end system user message, which is the initial user query, is user query. GPT API caller is OpenAI API call, which is the class we define right here. And our system messages and the name of the project comes from self.generate system messages, which is a method right here. And we give it here we have a list of messages which we're going to send, and a function definition, which includes system messages as array, distinct and unique system messages. And then name of the project, briefly describe the name of the project. They both are required. So we are defining these as separate lists. But at the end of the day, when we are making the API call, we are still relying on the GPT API caller's call API method. And remember, GPT API caller is the OpenAI API caller, which is our class which we have defined originally, which handles all our API calls. And then we give this, when we are actually making the API call within this generate system messages method, within the Swarm class, we give it the model for the system message generation from the configs. We give it the messages, which we have defined right up here. And then we give it the functions and the function definition list, which we have defined right here. And then the function call is the function call, which we have defined right here. And then we check for responses, and we receive the system message and name of the project with JSON.load responses. That's the system message key from the JSON.load responses, and then JSON.load responses, name of the project. This is the line, and then we return them. If there is no responses, then we return empty. Then we have a GPT call method, which deals with each of the agent's answer we are still using the GPT API callers call API method. We set a word limit using the response tokens length. We actually take away 1/3 of the response tokens length. This is a rough calculation of how many words, however many response token length we have specified is. And then we define our messages. We input the system message, which is automatically generated. Then we input a user message saying, please answer using no more than our word limit, which we have specified here. And then we enter the user message. And here, when we are calling the GPT API calls call API, we use the model for answer generation from our config class. Then we have a method to write responses to JSON. Here we are doing that. Then we have synthesized responses, which is another GPT call. We receive the responses, okay, which are all the responses which we will be generating from these calls in a parallel fashion here in a moment. And once we have them, we will have, in this case, let's say 5 answers. We join them as a string, and then we create a prompt based on the following responses, provide a comprehensive and concise synthesis, and we give the joint responses. Then our messages is, with the system message being, you are tasked with synthesizing multiple answers into one comprehensive response. Read each one carefully and synthesize them. Then as the user message, we insert this prompt. Then we simply get our synthesized output by calling the GPT API caller's call API function using the configs model for synthesizing final response and messages. Then we simply define an output path with the directory structure, and then we write it to the necessary file. And then we have the generate response general method, which uses the thread pool executor to map the GPT called to all the system messages. This is our initial responses, right? Because in this code, we only deal with initial responses. And then we synthesize those responses with the synthesize responses method. And we have a main loop, which takes in a user input. And then we assign the GPT API caller to be the OpenAI API caller and swarm to be the GPT swarm with the user message and GPT API caller as the OpenAI API caller. And synthesize response is what the generate response method generates. And then we just simply print it. And we also save them to files as well. And then we run the main function. And here is the small documentation for this code. Now let's review our real deal file, the swarm GPT agent communication.py. Before we do that, I just want to mention, if you visit my website at www.echohive.live, you can search and find all the videos I have generated along with their descriptions and the code download links at Patreon. And you can easily watch them here as well. I have over 170 projects, although it says 140 here. I just haven't updated it yet. But the videos are pretty up to date. I update it every few days. Like I said, these code files will be available at Patreon. Link will be in the description. So this is going to be pretty similar to the previous file, which we have reviewed. We are doing all our imports, and we have a config class with the exception that we have feedback rounds here. So we can generate as many system messages as we like, and then we can specify as many feedback rounds as we like. Of course, it'll take longer and cost you more tokens. And also pay attention that if you have too many system messages and your response length is too high, then you might run into token limit issues. Okay, so let's just keep this 1,000 then, just in case. Model for system message generation. If you use GPT for all, then obviously you're going to get the best response. And the difference is here. Another difference is that we have a model for answer iteration here as well. So preferably you can just do this. This will generate the system messages one time, right, with GPT-4, and then the original answers with GPT-4. And for iterations, you can use GPT 3.5 Turbo 16K, and for the final response synthesis, GPT-4, for example. This might be an ideal situation. So this way you can really crank up the feedback rounds. Anyway, we are defining our OpenAI API key. This is a cool way to define. Either get the API key from your environment variables, or you can insert it here. Okay, then we are defining again the OpenAI API caller. We have exactly the same situation here. We are defining a GPT called for parameters dictionary, and we are having conditions, whether if you're going to do function calling or not. So all of this remains the same. And in the GPT swarm, almost everything remains the same, except I believe here we are generating a base directory called swarm work. And then we are defining a project directory based on the name of the project. So swarm work directory is generated, and then we generate another folder with the project name. And then we are checking these directories exist or not, both the base directory and the project directory with this method. Then we have the generate system messages, which remains the same. Okay. And our GPT call, which remains the same. Write the response to JSON remains the same. Synthesize response, I believe, remains the same. Except now we have a new method called feedback loop, which takes in the current responses. And we iterate over that. And using thread pool executor, we list the zipping of system messages with all the current responses, time the system messages, length. The reason why we are doing this is that, remember, we are generating originally, in this case, 5 unique system messages for guidance of the agents in our swarm. But we also, while iterating, want to give all of the other responses that were generated. Okay, so we want to give it a single system message along with all the responses that were generated. So what we're doing here is that we are generating 5 of these. So we are creating a list of however many system messages there are. We are generating one system message and all the responses that many times. I hope this makes sense. Then we get the updated responses with the executor mapping the GPT call with feedback with the args, which we have defined right here. And then we update our current responses with that. And then we write responses to iteration file, which does this, right? We write the JSON and then write to iteration files. We use a different method to write that, which is defined right here. So this is another difference from the previous file. We do have the, I believe we don't need this, file name, which is based on the project directory, and the iteration number, so that we can accurately number them, just this. And then we simply just write them. After, of course, zipping the accurate system messages and match them to the response. And then we have GPT call with feedback, which takes in the args, right? We talked about this. Okay, we say we get all the responses because we are going to feed it in. We can say, consider these other approaches carefully. Write your solution to this problem, having considered the best aspects of all other responses. Add missing features if necessary. I believe this is very coding related. We don't need this. We want to keep it as general as possible. We want our swarm to work for many use cases, right? Okay, and we set our word limit based on the response token length. And our messages is the system message, our prompt, which we have specified here. And then a user message, which says, please answer using no more than word limit words. Do your best given the word constraints, return only your answer and do nothing else. We are saying this, do your best given word constraints, because if you have a very small token count, it may start, GPT might start apologizing, saying that it cannot provide that answer with the given word limit. And then we, again, use the GPT API callers, call API. Remember, GPT API caller, we have specified up here. GPT API caller is the OpenAI API caller. OpenAI API caller is our original class, which handles all our GPT API calls. That's why we created this call parameters, so that we can do both function calling and regular API calls. Here in the GPT swarm, we are instantiating an instance of that class as the GPT API caller, and for all methods such as system message generation, original answer generation, or iterative answer generation, or synthesizing responses, we use that method in every case. We use that class and call API method. And then we have the generate response with thread pool executor. We, again, get the initial responses, write the responses, we get the feedback responses, and then the synthesized response, we return the synthesized response. In our main loop, we get the user message, whatever it may be. It can be anything you like. We define GPT API caller, pass that to GPT swarm. I believe we I'm actually having a duplicate here. It doesn't matter. I mean, if you're familiar with object-oriented programming, this is you can figure out however way you want to handle passing of one class to the other. Anyway, synthesize response is swarm.generate response, and then we just print it. And while all this is taking place, we also write each and every one of them to the files as well. So this is pretty much it. Maybe let's run it one more time so we can see it. Again, we'll use the comparison. When we run it, we're going to start by initializing the swarm. And then we are going to create our distinct system messages. You are a database expert. You're a data analyst. You're a software engineer. You're a system administrator. You're a business strategist. And here's the name of our project. As you see, this is a function called response. Maybe we can, and then we're going to generate initial responses, and then we're going to iterate. And that is the communication part, right? Because every agent gets to see what every other agent has answered as. So in the generate system messages, we are given the system role of a system messages used to guide a large language model to solve a user's query, provide a list of system messages, and many system messages, many distinct and unique system messages to guide a large language model to solve the user's problem from different perspectives. System message addresses LLM as you and gives it a role, direction, and scope such and so. And we have a function definition, which is called generate system message. Description is generates varied and distinct system messages. So this is how we are able to generate these system messages with a function call. We have system messages array. Each of its items are going to be strings as distinct and unique system messages, and name of the project is a string. Briefly describe the name of the project. Okay, so that's what we were doing right there. And as you see, we are probably overriding this. If it has the same name, then it's going to override, but nevertheless, we generate an initial response, then start the feedback loop, swarms communicating, and we write those iterations to file. And once the final iteration is done, then we write the synthesized response, such as this. I hope you enjoyed this. Like I said, this code files, along with 120 plus projects, is available at Patreon. And also there will be a link to the Echo Hive Discord server in the description. Feel free to join and chat with us about all things large language model related. And if you like the content, please like and subscribe, and see you in the next one.